Good morning. So here again today we have another snow day, and I would like to record my lecture on this video so you guys could watch, and hopefully you'll be able to do your homework. If not, I would like you guys to post your homework question on Facebook, and if I have time today I can come back on my iPad and show you some more examples. But in this video I would like to talk about another method of integration. So the first method we have learned so far is integration by substitution, when we had to choose the function u, which is the inside function, and then we have to substitute the x by the u and then do all the integration. Now here today we would like to talk about another method, which is called integration by parts. Now since we don't have a lot of time, because this video will be short, so I'm just gonna go ahead tell you the formula for this integration by part. The formula is integral of u times v prime dx equals u times v minus integral v times u prime. Okay, and I really want you guys to memorize this formula. Now, at the beginning you might just write it down and then look it up, every time when you practice on the problems, but later on I'm pretty sure you will be able to memorize all this yourself. Okay, so I would like to start from this example. Number 1. Integral x e to the x dx, like this. Okay, so when you look at this integral, it looks pretty simple. However, if you're trying to look through all your formulas I gave to you earlier, or trying to use integration by substitution, I'm afraid to tell you that it's impossible without this new method here, integration by parts. So what's so special about this type of integral? You see, there are two functions. The first one is the x, and the other one is e to the x multiplying, right? You got multiplication of two functions, and as you notice, these two functions are in totally different types. Like the x is linear, right? Or you can call it polynomial if you want. Let's call it linear. It's linear because it's polynomial with degree 1. Now the e to the x is exponential, right? It's exponential. It's two different type of function, and you multiply them. So here's the problem. We got multiplication of two different type of function, and so far we don't know how to do this, right? Because we have not learned this integration by parts. Alright, so I'm just gonna show you how we're gonna do use this formula and trying to evaluate this integral. So now you got two functions here. What we need to identify, so here is step 1. We need to identify two functions. First one is u. Okay, the other one is v prime. Now u times v prime should be x times e to the x. So you have two choices. First choice, u is x, v prime is e to the x. The second choice, u is e to the x, v prime is x. Now how do we know which choice should we choose? I'll tell you some tricks a little bit later, but at this time I'm just gonna tell you here is the correct choice. U is x, v prime is e to the x. Okay. So now, let's choose that, and then next step, we want to look at our formula right here. Okay, the right hand side. Integral u times v prime dx is u times v minus integral v times u prime dx. So you see, you need u, you need v, and you need u prime. So 3 things you need, right? 3 functions. We already have u, we don't have v, or we don't have u prime, but we should be able to find v and u prime pretty easily. U prime is just the derivative of x, which is 1. Now right now we got v prime is e to the x, so to be able to find v, we look for antiderivative. Now antiderivative of e to the x is just itself, so there, e to the x. Now we're done with step 1. Step 2. Okay, we're going to apply the formula. So you start with original integral, okay, which is your x is u, your e to the x is v prime, and we're going to use the formula. So integral u times v prime dx is u times v minus integral v times u prime dx. Alright, now this is in step 2 still, so we're going to apply this formula by using what we have found so far. We got u, we got v, and we got u prime. 3 things we need for your formula. So go ahead and substitute all this u, v, and u prime into your formula here. So your u is x, your v is e to the x minus integral, your v is e to the x, u prime is just 1. Okay, so there, so far we have. Okay, now we're going to change to another page. Okay, so I couldn't figure out how to turn to another page, so what I did, I just shrinked what I have written so far on the left hand side so you still can see it, and now I could continue. Alright, so we got what we have so far from step 2, okay, is integral x e to the x dx equals x e to the x minus integral e to the x dx. Okay. So now step 3, we're going to finish up all this. So we're going to take care of the last integral here. Now we know that the last integral is in integral e to the x dx. And go ahead and find this integral. This just asks you to find antiderivative of e to the x, and it's again just e to the x plus c. Oops, my x. Plus c. So there, final answer, okay, of this integral x e to the x dx is x e to the x minus e to the x plus c. So that's the final answer. Okay. Now I mentioned earlier that I'm going to tell you how to choose u and v prime. Okay. it's almost 10 minutes here, so I would need to create another video. So let's stop at this, and then we continue to the second video.